Welcome to this demonstration of how to measure a gear, using Arco inspection software. Inspection software Arco measures helical and spur gear, internal or external. The gear we are going to measure is built on the nominal, as described in this slide. The first step is to build a suitable probe configuration. Due to the span of the PH10 head, the T configuration is preferred in order to reduce the CMM error. Now we are mounting the probe in the PH10 head, and then we make sure to have the stylus properly aligned, in order to avoid the so-called shanking during the inspection. A shanking is a false measure that we get when the part is touched by the shaft of the stylus and not by the ruby ball. This is normally due to a misalignment. The probe calibration is the mandatory procedure to guarantee accuracy. By calculating all the offsets among the different head orientations, Arco will make sure there is no error during the head rotation. Start the software and then run the guided wizard procedure, to define the probe, and run the calibration. The wizard guides the users into the calibration. It shows all the necessary steps in order to have an error-proof procedure. First we define graphically the probe. The goal is to have on the preview, the same configuration as we have in the real CMM. The full Renishaw library of probes allow us to make sure that all possible probe configurations can be built. When the graphical probe is built, we select the required positions to perform the measurement. Due to the nature of gears, all the 7.5 degrees steps, on the roll axis of the PH10 head, are required. Now the wizard will guide the user into the rest of the procedure. The master sphere, to perform the calibration, shall be selected, the dynamic parameter for measuring shall be set, and, finally, the calibration program is automatically generated. The calibration program is a very simple task to be done. Arco will ask the user to manually locate the probe on the top of the calibration sphere, and then the rest will be done automatically by the system. To guarantee an even distribution of the points, the sphere will be located with a CNC procedure. All the defined positions will be calibrated without any further intervention from the user. Let's follow the full probe calibration for a gear inspection at accelerated speed. A full calibration of a probe might take several minutes to complete. Luckily, it is not a daily procedure. Once the correct probe offsets has been established by the software, this procedure shall not be repeated very often if no strong collision happened with the part. As you can see from the accelerated video, the user is not making any intervention while the CMM is performing the calibration. Now that the probes are ready, we can fix the part on the CMM bed. And now, we can generate the program to inspect the gear. Let's open the dialog in the software and fill all the dimensional parameters of the gear. Those numbers come from the design of the parts and shall be simply copied in the user interface. Once the gear is ready, the user can appreciate the CAD model of the part. Now is time to select the probes to be used for the inspection. Arco will choose the correct probe for each individual point. In this way, the shanking risk will be minimized. As you can appreciate, the full automatic program has been created by Arco. The number of points to be used for the involute and the lead line can be chosen by the user. For each point, it has been set the maximum possible approach distance, and the two measuring diameters are clearly previewed in the model. the user can change and preview all the measuring path as well as selecting the required alignment type. The available alignments are cylinder direction and center, plane and circle, 2D synchronization, current alignment as per the customer definition. Once all the choices are made, the full automatic program is generated. The program created by Arco is fully functional, and requires very little expertise to be run. It is just a matter of following the messages to create the manual alignment, and the program will run automatically. On this demo, we chose a plane to circle alignment type. We first measure 8 points on the plane when asked by the software. Now we continue by touching another set of 8 points to define the center circle. And finally, we move the probe in front of the first tooth we want to measure. Again, no user decision has been made so far, we just followed the instruction given by the software. Last confirmation is the permission for the CMM to move automatically. Now the job is done. Let's wait the inspection to be completed. First the CNC alignment. And now the measure of the lead line, the involute on both left and right side, then, if required, the measure of each individual teeth for the step and run-out error evaluation. Let us assist the full measurement of the first tooth, then we will accelerate the video. Okay, let's wait the results. The last two commands of the program will generate the PDF reports. Again, no need of any intervention, all is automatic. Now, the user can collect his PDF report opening it directly in Windows Explorer. The report is a standard gear report document, the lead and involute lines are clearly represented. The quality is defined according to the international standards. The second page shows the pitch, flank, tooth thickness and run-out error. The document can be customized with company logo and design details. Now that the standard gear measurement has been achieved, if we move to the CAD view of Arco, we can notice that the solid model of the gear has been used also for a standard model inspection, therefore we can find a color representation of the surface deviation. Thanks for assisting the full demonstration of a gear measurement with Arco inspection software. We hope the explanation fulfilled all your questions on the potential of this optional module of Arco software. If you have further question, please don't hesitate to contact us.